All right, it is June 30th, and I have not made a video for my channel in quite a while, so I thought I would touch on this since there seems to be a fair amount of reporting out there about sea ice extent at the North Pole and the Arctic and so forth, and a lot of talk about how it's so far less than it should be up there, and I want to show you that that's a matter of perspective. And so I'm going to try and make this as quick as possible as usual and just kind of point out some things that you may not have seen or heard before about the sea ice extent, just for your information. Okay, now I'm going to start this one out again by saying I am not an expert, but I am a researcher. I'm an analyst. I look at a lot of data, and I've been trained to analyze large amounts of data. So in one respect, when it comes to understanding the physics and what's going on up there, I can look at the data and pull together some pretty reasonable conclusions, and so that's what I'm sharing as a part of this video. You make the call. I have seen some pretty obvious evidence that the climate conditions that we're seeing recently have nothing to do with CO2. In fact, it just seems ridiculous, according to the data, to believe that that's the driver at all behind our current climate changes. I'll put out there that I believe that what is happening is we're in this grand solar minimum, so we are seeing some incredible changes. Now, some of the changes are not scientifically attributable to the grand solar minimum necessarily. Of course, we don't know a lot about what happens to our planet during a grand solar minimum, but needless to say, even the things that seem to be an anomaly according to grand solar minimum expectations for changes on our planet, it's those things that are in that area of confusion or misalignment with what the expectation would be, still are even like further away from the potential of CO2 being a factor. So, okay, that said, let's look at what's going on. If you're still with me and you're willing to kind of consider looking at the actual data and trying to just draw some conclusions, let's take a look at this and I'll show you what I've found. This is the sea ice concentration. Of course, it also shows the extent, and you can see the orange line represents down here in the bottom the median ice edge between 1981 and 2010. So according to that average, yes, if you saw this in the news, you'd say, holy cow, we're melting away. For context, Al Gore said there would be no ice up there. We're in the middle of summer now, and so hitting July, and there's still an awful lot of ice. Also, you notice the color scale on the right, so the darker blue, the thinner or the less extent. Like when you get into the really, really kind of darker blues, it means that it's not even solid ice. Like you wouldn't walk on that. It's just giant chunks of ice, 10%, ice floating around. Okay, so it doesn't mean ice and no ice. It means that the ice is very thin, slushy. It's 10% ice is the way they look at that, or 20% or 30% depending on the color gradient that you see. Okay, of course, white is definitely solid ice. Now we're going to take a look in a minute about sea ice. We're going to take a look in a minute at sea ice thickness, and that'll give you a very different picture of this as well. But that's for in just a moment. So let's look at this. We are seeing. This would be if you've seen my earlier videos, where the Atlantic conveyor belt comes up and brings that warm water up toward the Arctic. And it naturally melts this close to the Arctic. Okay, so that's why this is not even in the average or not average. This is just always kind of melted over here, particularly this time of year, right? So we're getting extra melting on the edge of Greenland, which tells me we got warmer water conveying up and melting the ice. Okay, this is Iceland out here and so forth. Now, this area is a little more interesting, because a part of this could be that we've got warmer water coming up in the conveyor belt, but the conveyor belt kind of stops here and then turns around and heads back down in deep water. And so it comes up on the surface, it turns around and it goes back below itself, so to speak, in deeper water, back down toward the equator. So what's causing this melting? We'll take a look at that in a minute. If you've seen my earlier videos, you might already have a clue on that one. But the circulation here is going this direction, like counterclockwise, okay, around the Arctic Ocean. And you see these giant holes, okay? Now this circulation goes up and then it turns and it comes out this way. Then there's a current that goes down the coast of Greenland. So cold, cold water under the Arctic washing down this way. Okay, so give you a little bit of insight. What else do we see here? A lot of news about Alaska and the melting over here. This is significant, okay? And again, if you're thinking this is warm air, well, I'm going to show you why that's not the case. And also over here, Hudson Bay, the melt is greater in the top. But look, the melt is far less. This should be melted over here. And just clear water. So interesting. And we'll take a look at that. Okay, and that's enough to take a look at it. I think I'm also going to mention this area here. So please make a note that there's a giant hole in the ice between this island and this island coming into Russia. Okay? Because this is one of the more interesting things that I'm going to discuss. And I have not talked about it before. All right, so there's our sea ice concentration, sea ice extent discussion. Let's take a look next. What do we want to look at next? Well, let's look at the thickness. All right, so same picture, different idea. All right, satellites gathering data on thickness. Now, the first thing I want to note, you see the thin ice here. Let's see here. You can see, purple all the way to white. That's thin. Then you go through blue, green, yellow, and red for really, really thick, like no icebreaker. Really, icebreaker is going to start about here. 3 meters thick is very thick. And so icebreakers can only get through, really, 2 meters and down. And this would explain why, and you see how far to the edge of the Arctic region this area is, how far south. And it's frozen. In fact, there's ships trying to get Russian oil out that are stuck in this ice right here. They certainly didn't expect it to be that thick. So that's interesting, right? Meanwhile, it's very thin coming up from there. All right, let's scroll on up. Look, you can see the giant holes in the ice that I showed earlier, these big gaps, and this is June 29th. And then you see this area. You notice how it comes right up through here. And I've talked about this in earlier videos, but the Mid-Atlantic Ridge comes through Iceland. It comes up this way. It turns right here and heads this way. And then it comes through here, very thin ice. And it comes right up that line and right over into Russia. Okay, that's the fault. And that's why this is so interesting. There was a huge, a very significant, I should say, sort of a heat anomaly that showed up over here about a month ago, and it melted a hole in the ice that's far bigger than was expected. So again, this was warm water, and I have not found anyone who could explain what that is, but I'm going to show you an idea, and it has to do with this straight kind of line here of thinness, and then you got thicker ice, and then you got this really thin area here, and this is the Mid-Atlantic Ridge, okay? And I'll show that. In fact, I can show it to you now. There it is, okay? So here's Iceland. The ridge comes under Iceland. There you see it showing up. It hangs, a left or whatever coming this way. There's this pocket, which I talk a lot about, and I'll show you in just a moment. It comes over Greenland and then shoots straight across and comes up right in between these two islands, okay? So we have a warm area right above the Mid-Atlantic Ridge as it crosses over and heads into Russia, okay? We also have, and I'll show you, an extreme hot spot that's been there for years, right here off of, I think this is called Salved Island, and it's melted everything. There's another hot spot further over, and we'll take a look at that. Okay, this is sea ice temperature anomalies, which means they take the average of temperature of water at the surface, and this again is satellite data, and they take the last 15 years and average it, and then they look at current data and say how far above or below is the water temperature now, compared to the average. So this is the sea surface temperature anomaly. Anomaly meaning, is it higher or lower than average? Black is average. As you get into blue and light blue, below average. And then as you get into the reds and yellows and then eventually white, it gets way, 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 above average. These are serious anomalies. Now, I'll note, just for kind of educational and to help understand, that what I've learned is that the reason you see these cold areas next to hot areas is actually an indication of warmth, as ironic as that may seem. But if you just think through, your science classes in school, or if you've ever made ice cream, then you can start to understand how this works. These black areas are frozen fresh water, right? So the frozen area is fresh water. Under that is salt water. And when you make ice cream, what do? You put salt in ice, and it melts the ice and makes it actually colder. So the melted ice is actually colder than the freshwater ice itself. So what happens is, if you have a warmth anomaly that starts to melt the ice, well, the fresh water disappears, right? It evaporates off, it moves in the currents and so forth, and what you're left with is colder salt water. Okay, so this would actually be warmer than normal, but it hasn't been exposed in the past. That's kind of what this is saying right here. So now we have actual seawater, salt water, which is colder than freshwater ice that used to be there, if that makes any sense. I thought I'd take a stab at explaining that, but that's why you see black here means ice, normal temperature, freshwater ice that forms from snow and so forth. And then down here is where we're looking at salt water that's not frozen, because it has to be a lot colder for salt water to freeze. And that's why it's showing up as being colder, despite the fact that it's a warming trend, right? There is no freshwater ice on top of it. Okay, so anyway, I'll take a stab at that. If you want to look that up, you can see it. But you can see fresh water coming in via rivers, warm, warm, warm. And as it moves out, it's a little cooler, but it's warm, and then this is where it starts melting the ice sheet, and so you get this cold saltwater effect of this blue. All right. So anyhow, look at this area here. Okay, and if I click in it, you can see it's white. So we're talking 15 degrees. I think some areas are even higher than that. Maybe not. But there it is, 18. I've seen it as high as 20 or above degrees above the 15-year average, and this thing has been there for years. That is an underwater hydrothermal vent, and there's another one over here. Both of these have been here, and if you've seen my earlier videos, you've seen them for quite a long time, and they're there now. If I go back to Google Maps again, we can see. All right, here's the Mid-Atlantic Ridge. It'll get more clear. And there is our giant hydrothermal vent right there, bubbling up like crazy. Okay, so that's how that works. Now, if we continue looking around, we can also see. All right, I know it's all upside down. I'll try and spin it around so maybe we can make some sense of it. There's Alaska. Okay, and what are we seeing here? I mean, again, see the rivers coming in? 10 degrees above normal. And all this warm water, the river coming in, again, it's wider here. But we've got underwater thermal activity happening in this entire region of the Bering Sea, right? This current pushes right through the Bering Strait, and right up under the ice sheet. All right, let's go back and look at our thickness. See how thin it is? Remember, purple equals super thin, right? And the sea ice concentration is the same. Okay, so again, we're showing evidence of melting, and I'm telling you that this doesn't have to do with air, but I think that the real telling sign, the most important data to look at right now, because the question is the Arctic Ocean melting? Okay, and we can agree it is. It certainly has less extent, and in some areas, some really unique thinness or just disappearance at certain points. So is this a sign of global warming? I mean, is the air changing and so forth? Well, the air is changing. But again, the root of the question is the Arctic melting? So let's look at this chart here. All right, and if you look, you can see 2014 is the red line. All right, so very low, or I should say high extent of ice volume in 2014, and then they show these down below, and of course the gray line is the average. Ooh, the blue year went way low, and so forth. But black is this year, and look where it's tracking. Okay, so it was in the lower, below average here as we came in out of winter into spring, and right now we're actually showing thicker, more ice volume at the North Pole than we have seen since 2014. That's interesting, right? If air is melting the ice, why would we see that? Why wouldn't it be less, right? And so it's interesting because air is kind of everywhere, and we've certainly seen the wind currents and the jet stream has been, instead of pulling around the Arctic, it's been doing a lot of crossing the Arctic. In fact, I can show you that. Let's look at air. Let's go to jet stream, and I'll turn on the animation. Let's back up. All right, so look. First of all, our jet stream is totally messed up. It's very, I'm going to call it weak and lethargic. Okay, that's just how I would describe it. Usually it's a lot more concentrated, but you can see that it's just meandering all over, all across the North Pole, stirring things up, pulling cold air down, pushing warm air up. This is a really interesting process of mixing warm and cold air that, instead of going around the planet, is actually just everywhere, mixing the air up and pushing it around. So if there was an opportunity for air to melt the ice, it would seem that that would be happening right now. Okay, so for comparison, I'll say take a look at what's going on. Man, this is messed up with our jet stream right now here. And then I'm going to flip the Earth over, and we'll take a look at the South Pole. All right, it's still a bit chaotic, but do you see how it's going around? Okay, and the cold spot in the middle, we've got some meandering across, but generally speaking, the jet stream is going around and keeping that warmer air down further away from the Arctic, which would maintain colder temperatures at the poles. Okay, again, we'll switch over. Remember, it's a spinning ball, so the North and South Pole are very similar in a lot of ways. But yeah, this is what we've got going on in the Northern Hemisphere. Okay, so I hope this helps to explain it to you. I struggle sometimes to really find ways to explain this without going too deep into the science. But I think one other thing I was going to show is that back in the late 2000s, 2008, 2005, they were really talking about how this right here opened up. This is called the Northern Passage, and it was free of ice. And they were saying this is a sign that Al Gore's right and the melt is coming, and so forth and so on. Well, look, I mean, red is extremely thick ice, and this green and blue, you can't get an icebreaker through a lot of that area, right? So the Northern Passage is iced up right now. The anomalies that we're seeing are on the other side of the Arctic, and they are directly attributable to warm water patterns and heat coming up out of the Atlantic, the Mid-Atlantic Ridge, or the fault line, right? Which is where we would normally see a lot of hydrothermal activity bubbling up. So this should be red, and it's actually very thin. You could run an icebreaker right up to the North Pole. Okay, so yeah, that's what's going on in the world. Is the Arctic showing signs of thinning in strange places? Yes. Is it attributable to air? No. Is there any way that it makes sense to attribute this to CO2? Absolutely not. This is warmth coming up from the bottom of the ocean that's heating the water, that's pushing the water in the currents up, circulating it around the North Pole, and melting our ice in the places as indicated. It just lines up that way. Have a great day. I hope this was helpful.